Please continue to explain yourself.
What do you mean by continue? I barely started the lesson.
Okay.
So a unit circle is this idea of we always have a right triangle with a hypotenuse of 1. So if I were to say 30 degrees, I'm saying that this angle right here is 30 degrees. And I would say the y value, our opposite, is 1/2. And this side is 3/2. So if I'm correct, then I would say 1/2 squared plus square root of 3/2 quantity squared equals 1 squared. So 1 times 1 is 1, 2 times 2 is 4. Square root of 3 squared is 3. 2 times 2 is 4. 1 squared is 1. And 1/4 plus 3/4 is 1. So this holds true. So just think about it that way. A unit circle is literally a bunch of right triangles. The reason why it's called a unit circle is the radius is 1. Does that make sense?
Yes.
So because it's 1, this ends up being half of the radius. So one way to remember the unit circle is sine of whatever degree we're talking about is equal to its opposite over hypotenuse. But if the hypotenuse is 1, then sine is always equal to our y value. Cosine is always equal to our x value because it's the adjacent over hypotenuse. But the hypotenuse, again, is 1. So if this is always 1, and our adjacent is always going to talk about the x value. So that's a quick, easy way to remember the x and y values. Sine. So if I asked you, what is cosine of 30 degrees? I'm asking you, what is the x value at 30 degrees? The x value at 30 degrees is this. If I ask you what's the sine at 30 degrees, that's this right here, our y value. And this theta, this is just pi. 2 pi is a circle. Half of a pi, half of 2 pi is 180 degrees. So pi equals 180 degrees. You cut pi in half, pi over 2.
You get more pi.
You would get less pi. If you're cutting something in half, why would you get more pi? That doesn't even make sense, Garrett. Come on.
Yeah, it does. What do you mean?
Wake up.
Cutting it, you're getting more. Think about it. You're dividing it into more pieces.
You're getting more pieces. You're not getting more pi.
Yeah, you want to bet on that?
If you cut it again in half, cutting it by 4, that's 45 degrees. So the way I always tell people to remember this is you're going to remember these a little differently. You're going to remember the 30s together. So all of the 30s make up one thing. Because a third, 1/3 is 2 6s. So 1 6, 2 6, 3 6, 4 6, 5 6, 6 6. The only thing is this gets reduced to 2/3. This gets reduced to 1/2. This gets reduced to 1/3. And the other ones you're going to memorize are these ones, the quarters. 1/4, 2/4, 3/4, 4/4. The only difference is this one gets turned to 1/2. So there is going to be overlap between the thirds and the fourths, but for the most part, they're kind of isolated. Does that make sense?
Yes, senor.
Cool.
What? I don't remember this.
Why is there like dialogue at the bottom?
What?
My screen, like when we're talking. Hold up. See,
Oh, there is. This is the captions.
when was there captions? That's so cool. My mind is blown.
Oh, it says turn on captions right there. You can turn it on.
Wow.
Ooh.
Well, let's go back to the unit. But that's kind of a quick overview about the unit circle. I'm sure we're literally going to cover the same stuff right now. So the objective is we're going to learn how to use the unit circle to solve for trig. Literally what I just did right now. So this is talking about radians. Radians is just a measurement of pi. It's a fraction of pi. So for example, one pi is this. So that's the measure using radians. R. So R is just going to be how long this is. So that's why the thing for circumference equals pi r squared. If we're talking about 1 radian, we're talking about when this is just the radius. I just like to think of it in terms of pi. Radians are usually when we're talking about pi. So 360 is 2 pi. If we cut it in half, literally all the stuff I said earlier. Pi, cut that in half, cut that in half. If we did a sixth of it, 180 divided by 6, pi divided by 6. So 180 divided by 6 is 30. Pi divided by 6 is pi over 6. That's all they're doing here. The conversion rate, to remember this, it's always pi is equal to 180 degrees. So if you want to change 360 to units of pi, it's 360 times pi over 180. If you want to convert 2 pi, it would be pi over 180. You're always using either this fraction or this fraction. Now I realize how much I talk because I have my captions on. All right, so here you would always want the pi's to cancel out. Here you would want this degree symbol to cancel out. And that's a good way to kind of remember how to convert it from pi's to radians. Oh my gosh. They're going to go over the proof of why this works. So if we have an equilateral triangle, this is 60, this is 60. But if we cut this in half, and we're going to assume that all of these have a side of 1. If we cut this in half, what's going to happen here is this is still 1. This gets cut in half, so it's 1/2. This is now 30 degrees because it's cut in half. So now we have a 30, 60, 90 triangle. 90 because it's perpendicular. 60, that's this angle right here. 30 because this angle is 30. And now we're just going to fill in the blank. So this is 1. This is 1/2. And this we would call x. X squared plus 1/2 squared equals 1 squared. This we would just solve and we would end up getting this. So that's what they're doing up here. They just kind of move this over to be like x squared equals 1 squared minus that squared. Does that make sense so far? It's too early in the morning for you?
I had to wake up at 9 because I had a meeting with like some other guy. Then I would have wait at like 10 because I basically just have 3 meetings that are an hour long. You're my last one, so I just want to.
You're like, I want this over with so I can go to sleep now.
You pretty much, yeah.
All right. We'll get there. This is a short lesson. We might be able to do the whole
Yeah, I
thing.
know. That's why I'm fine with it. That's why. It's the last one. I know that you like doing short lessons, so that's why I'm patient with this one. The other two, I just wanted them to end as fast as possible.
So here they're just talking about all the stuff I already said. Opposite over adjacent. So if I'm doing sine of 30, so this will help us with two different ones. This helps us with if this is 30, and it also helps us with if this is 60. So this triangle, we can imagine takes up, where is it? This one right here. It's going to take up this triangle and this triangle. So that's how come we have these two right here. And then remember how I did, where am I? How I did the yellow ones. So if we're doing the yellow ones, that's going to be talking about this. We're talking about, we're still finishing this up. So this is a little tricky. Obviously, if we're talking about pi over 6, we're talking about 30 degrees. And again, if you guys don't have that memorized, it does take time to kind of remember it. I always remember it as, I just remember pi over 6 is 30. So if I have 2 pi over 6, I'm doubling this. This is 60. So that helps me remember that pi over 3 is 60. You guys can use the unit circle on your test. I just like having it memorized because it just makes it faster. So if I'm talking about 30 degrees, the way I usually remember this is I remember my 30, 60, 90 triangle. And I remember that the short side is 1/2 and the long side is this. The reason why this is easy to remember is if you look at a unit circle, just think of it as square root of 1 over 2, square root of 2 over 2, and square root of 3 over 2. 1, 2, 3. Those are the only possibilities. So if I'm talking about a long side and a shorter side, I'm talking about 1/2 and square root of 3 over 2. You can pretend this is a square root to make it easier. So I'm talking about 30 degrees. I'm talking about the adjacent side. So I'm talking about square root of 3 over 2. So I'm going to bring this down to square root of 3 over 2. 1/2. So that has to be the longer side. So that is either the sine of 30 degrees or the cosine of 60 degrees. Well, we don't have the sine of 30 degrees, so we're going to have to do the cosine of 60 degrees. Does that make sense?
Uh, yes.
Okay. So the next one, we're still talking about our 30, 60, 90 triangle. But how are we getting these? If our only options are square root of 3 over 2 and 1/2, we would have to combine these somehow, right? So remember, if we're talking about sine of 30, our opposite is our short side. I didn't draw this good. Our short side. Short angle, short side. Big angle, 60 degrees, big side. Our short side would be 1/2, and our long side is this. So when we're talking about this, our opposite is 1/2. Opposite over adjacent, SOHCAHTOA. Opposite over adjacent, so 1/2 over 3 over 2. If you're dividing fractions, it's the same thing as multiplying by the reciprocal. So therefore, this would be 30 degrees. So 30 degrees is this. So we're going to put that here. And 60 degrees is the opposite. It's going to be the square root of 3 over 2 divided by 1/2, which is the same thing as Once we flip it over, square root of 3. Does that make sense, guys?
Yes. No.
For now.
For now.
I'm not gonna expect you guys to like do this off the top of your head. I'm gonna expect you guys to be like, all right, so I got this unit circle and I'm looking at this. So if I'm talking about TOA, I'm talking about my opposite. My opposite is always my y value, and my adjacent is my x value. So that's usually how you're going to do this. You're going to identify your angle, then you're going to identify your x and y, and you know that tangent is always opposite over adjacent, y over x. All right, so moving on. Now we're going to be looking at a 45-45 degree triangle. So this means, this one I think is the easiest one to remember. If this is 45 and this is 45, that means this is x, this is x. And if we're talking about a unit circle, this is always 1. So then we have x squared plus x squared equals 1. Well, that's the same thing as saying 2x squared equals 1, which is the same thing as saying x, blah, blah, blah. What am I doing here? X squared equals 1/2. So in other words, this is the same thing as saying x is equal to the square root of 1/2, which is essentially 1 over square root of 2. I'll get into, well, I'll just do it right now. I know they're going to get into it, but I'll show you right now. In math, I know it's going to be contradictory because they showed this, but in math, we don't like square roots at the bottom. So I'm going to multiply this by square root of 2, multiply by square root of 2. This cancels out, so we end up getting 2 square root of 2 on the top. This one was supposed to be, but they wanted to make it easy on you guys. This one was supposed to be square root of 3 divided by 3, because these cancel out. Square root of 3 times square root of 3 is the same thing as square root of 3 squared. So these cancel. Does that make sense, or did I go too fast?
No comment.
No comment. Did I go too fast?
Well, I have no idea.
So again, x squared plus x squared equals 1. 2x squared. Is this making sense so far?
Yeah, you're getting the x squared from the triangle, right?
Mm-hmm. Because remember, it's a squared plus b squared equals c squared. Our c squared is 1. These two are both x squared, so we can combine them. We divide by 2, so we get 1/2. And then we get x equals the square root of 1/2. The square root of 1 is 1. The square root of 2 is square root of 2. Basically, I forgot to show you guys this step. From here, we're going to multiply by square root of 2, multiply by square root of 2. Square root of 2 times the square root of 2 is the square root of 4. 1 times the square root of 2 is 1 times the square root of 2. There's not much we can do there. Square root 1 times the square root of 2 is square root of 2. Square root of 4 is 2. So that's how you would do that. I just skipped a few steps. I'm sorry.
That's okay.
So based on the figure, what is the value of x? So in this case, the value of x, I'm going to do it without simplifying. I'm just going to say the square root of x is the square root of 1/2. Submit it. They do all the, it's called rationalizing what I did. Rationalizing is we don't want a radical on the top. We want this normal-ish. Never. You don't want a denominator to be a radical. So that's why it's called rationalizing. You want your ratio to be a little bit better.
I swear,
Why do
So,
you think people learn it, man? Come on.
well, I'm not sure if you saw the YouTube video yet, Nick, but I totally forgot to look up that word for basing. And I keep trying to Google it and I can't find anything. So we're just gonna say the inverse of a log from now on. Because apparently there's no word for it. Or you can call it basing if you want to keep calling it basing. But inverse of a log, I guess, is the official name. All right, so what we're going to do here is what is the value of x at 45 degrees? So at 45 degrees, our answer is going to be square root of 2 over 2. So cosine is talking about the opposite. So our opposite is square root of 2 over 2 because we said this was a square root of 1/2, which is the same thing as square root of 2 over 2. So when you're doing this, these two are the same thing. That's why they say the or. They want you to get used to knowing it as radical or degrees. So our answer is just going to be square root of 2, 2. And they're just saying it here, opposite over hypotenuse, but the hypotenuse is 1. So that's what they're doing here. This is our opposite. This is our hypotenuse. But if you're dividing by 1, you don't really have to do this step. You can just go to this step right away. With dividing by 1, you're not doing anything. What's the cosine? Well, the cosine is our adjacent, which is also x. And since we said x is square root of 2 over 2, even if we do it over 1, that's still square root of 2 over 2. So 45 is one that's really interesting because it's the same thing. And because I'm lazy, I'm just going to copy this here, and I'm good. What is tangent? This one we actually have to do work, unfortunately. I'm sorry. I know you guys were looking forward to not doing work, but this is square root of 2 over 2. So you're going to have to use the fraction button like 3 times here. This is the same thing as saying square root of 2 over 2 times, we're going to flip it over. So if we flip this bottom fraction over, if we flip over our denominator over, what's on the downside? I always call the numerator north and the denominator down. That's an easy way for me to remember numerator and denominator. If I flip over my denominator, 2, and this is going to be 2, well, I got lucky. What happened here was this cancel out with this, and this cancel out with this. Lucky. And this is equal to 1. It's not lucky. I mean, it's just math.
I mean, you could calculate luck and be like, oh, yes, I'm the luckiest man alive.
So the answer is 1. So, yes, you have to do work, but 45 degrees is probably the easiest one to do work on. Now they're going to make it all complicated. This one, they gave you pictures. They're like, look, we know this stuff is hard, so we're just going to show you pictures. But this picture is just. What's up? Sorry.
No, look, you go.
No, what were we going to ask?
I was just going to say that picture looks like the blueprints for the Superman, right? Because I don't know.
What?
It just looks confused.
It's just 3 triangles. This one is a triangle 30, 60, 90. And this is a 45, 45, 90. And this is a 30, 60, 90. That makes sense?
think so.
So this right here, we're talking about, it's asking which one of these is the answer. So if we're talking about 1/2 for the x, our x is 1/2. So that would be this one. But is it the cosine or is it the sine? Well, x is 1/2. So x would be our adjacent and y would be our hypotenuse, right? So if we're talking about this, we're talking about our adjacent over our hypotenuse. So ka toa. So we're talking about the adjacent, which is the ka. So we're talking about cosine. So our answer is going to be cosine of I over 3. I of, oh wait, it's over 3. My bad. This is 60 degrees. They tricked me, guys. They tricked me. This is 60 degrees. We're talking about 60 degrees. I always get confused. I have to remember pi over 6 is 60 degrees. So we're talking about the y value here. So if we're looking at this, we're looking at this one. So this would be, oh wait, no, I got it right. Talking about the x value. What is the value of these? Oh, it's multiple questions. I thought it was multiple choice. I'm sorry. Let me answer these then. They didn't trick me. I was just confused, which I guess is the same thing. Pi over 3. If I'm looking at this picture, I'm saying, what is my y value? Well, my y value is square root of 3 over 2. And then because I'm lazy, I'm just going to copy this. I'm going to copy this, paste it here, change this word to cosine. And our cosine is talking about our x value. So I'm going to change this to 1/2. Boom. I'm going to copy this.
He's copy and pasting. Whatever.
I'm going to change this. Oops. The tangent. The tangent is opposite over adjacent. So that's why I did the sine first. Opposite over our adjacent. So this is really square root of 3 over 1, which is just square root of 3. So tangent is always the thing we're going to have to do the most work for. Because you have to do x over y. For sine, sine is just our y value. Cosine is our x value. Tangent is always our y divided by our x.
But why?
Because SOHCAHTOA.
But why?
Do we need to go over SOHCAHTOA again?
Yes.
Are you serious?
SOHCAHTOA. No, I'm just kidding.
Okay, I was like, so this one, we're talking about square root of 2 over 2. Square root of 2 over 2. So we're talking about our 45-degree triangle. So, oh no, my laziness didn't remind me to copy all of this. Now I'm going to have to do it all over again. All right, so sine of pi over 4. Pi over 4 again is 45 degrees. And this is going to be Square root of 2 over 2. Luckily, remember I said that cosine is 45 degrees is the easiest one because all you have to do here, for all you other lazy people out there, you just have to type that in. Boom, it's already correct because our cosine and our sine is the same. Tangent is going to be the square root of 2 times 2 over square root of 2. Cancel, 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 cancel. So it's just a giant 1. Yeah, exactly.
I think I'm getting the hang of it.
You think? it I'm doing it fast because I already have the triangles memorized, but like if you think it out, all you need is a unit circle and you can figure it out. X is your cosine, y is your sine, tangent is always going to be your sine over your cosine or your x over your y. In fact, I think that's a formula in here. Yep, opposite over hypotenuse, blah, blah, blah. Or sine is y, tangent is y over x. Yep, they're literally right here. So you guys can always print this out. It's in the class stuff. It's like the first thing I put.
Okay. Yeah, I have a printer. Can you fax it to me?
Did you say fax it to you?
How am I gonna fax it to you? Can't you just hook up your fax machine to your computer and print it?
I'm kidding.
Like, who has a fax?
Yeah, I'm pretty sure Granada had a fax machine. Yeah. I'm not even kidding, dude.
So, since 30 degrees is basically the opposite side of the 60, all of these are backwards. We're gonna just our sine is our cosine, and our cosine is our sine for when we're talking about these. And you'll see it right now. So first I'm going to do my sine. Oh, my laziness forgot to copy it again. Sine of
I
pi.
just want to know who woke up one day and was just like, man, came up with all this stuff.
It's just an evolution of the triangles. Everything comes down to this. So this is back from Pythagoras' time. So back in ancient Greece. So this is old stuff, guys. You guys need to catch up. This is old math.
No, it needs to stay back there. We need to discover something else.
So you want to go into quantum physics, is what you're saying?
Oh, hell, never mind.
All right. So we're gonna do sine, which is our y value, which is our 1/2. And then I'm just gonna copy this. Now I'm gonna do my cosine. What did I do?
Destroyed half the universe.
Please tell me this is a different recording. Okay. I was like, no, I'm not recording.
Heart drop. He's like, oh.
Like I done goofed. All right. For this, I'm gonna change cosine. Oh, I think what happened is I hit shift and backspace at the same time, and that did weird stuff. All right, so that's my cosine because it's the opposite. It's the opposite side. Cosine is our x value, our long side. Our long side is always going to be square root of 3 over 2. That's how I remember these. I remember them as short side, even side, so 45, 45, and my long side.
What do you even like? What do you need the unit circle for?
We're
Like,
just talking about it, right? That's literally what this is. If you have 30 degrees, it's the fastest way to remember that the height of our ramp is 1/2 of whatever this is. So if we have a ramp that's 30 degrees and this is 6, our height of our ramp is 3. If we wanted to figure out how long the ramp is, we would do 6 times square root of 3 over 2. So our height would be 3 times the square root of that. Or let's say somebody punches you with a force of 30 miles an hour this way, and it makes an angle with 30 degrees off the ground. How high, how fast are you getting punched up? How fast are you getting punched this way? Does that make sense?
That's like some Street Fighter stuff. Okay, yeah.
Another way of thinking about it is like, let's say you fell off of something, like you're here. So this is Nick, and Nick decided to run, and he didn't realize there was a cliff. So he's running this way, a certain speed, and then gravity's making him go down this way.
What if gravity made him go up?
How far is Nick gonna go before he hits the ground?
Yeah, I don't know.
That's what this is what trig is for. This trig kind of helps you figure this stuff out. Does that answer your question a little bit?
I was just asking what job. When do you use this in real life?
Physics? No, that's a fair question. A lot of people don't know when you use trig in real life. You use it in physics a lot. So if you ever want to be a computer programmer and you want to figure out the physics and stuff, they use trig a lot because it's the idea of two forces acting in different directions. And right now we're talking about the easy physics. We're talking about 90-degree physics. We're not even talking about the physics where you have a different angle. That comes into play later.
All right, that's good to know.
That's don't think of it as like it's a triangle. Think of it as it's two normal forces, two forces acting at a 90-degree angle. Later on, you'll deal with two forces acting at a different angle. This is when we start talking about vectors.
Oh, the vector scale?
Yeah, pretty much. No, but that's a good question. I know a lot of people think that it's dumb to ask when do you use this in real life. It's used in a lot more complicated stuff, like if you're doing engineering, if you're doing computer programming, advanced computer programming. That's when it comes up. So this, again, we're always going to do y over x. So y over x, which is this. You have to flip it over. So we end up getting 1 over square root of 3. Edmentum's going to want you to say square root of 3 over 3. I'm fine if you don't rationalize it. If you leave it as 1 over the square root of 3, I don't care. Just be aware that that's a possibility if it's a multiple choice question. Square root of 3. And then right here, it's just saying, how do we solve this if we don't know what these are? So now theta.
You look at the angle. Oh, that's a 60 degree. All right, so degree.
We don't know what
Pi
it
over
is.
3.
So I think you're making this harder than it is. Think of it this way. We're talking about sine of something we don't know. When we don't know something, we give it a variable. When we're talking about degrees, we call it theta. So sine of theta is equal to, you know this, sine of theta is equal to our opposite. What's our opposite? What's our opposite of our angle? What is this? Is it x or y?
All right, so this is a hold on, I got you.
So here's our angle. What's opposite of this? What's our opposite?
Y.
Yeah. And we don't know what our hypotenuse is, so I'm just going to call it h. I'm assuming, did it say it's a unit circle? Hypotenuse is blah, 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 hypotenuse, blah, blah, blah. So it doesn't say what our hypotenuse is. So you guys can leave it as just an h for hypotenuse. Edmentum wants you to do this. Oops, what? I don't want to take a screenshot. Edmentum wants you to solve for the hypotenuse. So hypotenuse squared equals x squared plus y squared. That's going to turn into this. You can just call it hypotenuse or you can call it AB. I don't care. And they also want you to do it for cosine and all the other ones. So if we do it for cosine, again, cosine is our adjacent. Our adjacent is our x over our hypotenuse. Or you can do it this way if you want to get really technical. And then our tangent, what's up?
No, I was gonna say I don't want to get technical.
You don't want to get
Hard enough
technical?
as it is. No way.
Yeah, I mean, it's not that bad because this is our hypotenuse and it's just x squared plus y squared equals h squared. How do you get rid of the squared? You just put a square root over it. That's how they got this. That's all they did. And then you guys can do your self-evaluation from there. Just tell me what you thought was hard. I'm sure Nick's going to write a lot of stuff in here.
Wait, Nick, you actually write stuff in there?
You guys are supposed to.
What is wrong with you?
Not really.
No,
I just
What?
put.
Weirdo.
Yo, what?
Weirdo.
Bro, I swear, calm down.
All right, guys. So that's all we're going to be doing for today. So next time I'll take off on slide 11. Slide 11 is just going to be a review of everything we did here. And then we'll do, this one will be a weird unit because we're going to finish it on a Tuesday. Unless, oh no, Monday. My bad. My mind thinks it's Thursday.